Record. So can you see my screen?
Yes.
Yes.
Yep.
Okay, perfect. So first, before I start, there is an issue. This is the course, okay? This is supposed to be the course you're going to take. I have just this one in my system as a basically cloud computing course, but when I go to the people, I don't see anyone's name. So I assume that's the problem. You don't see any content in the canvas. I already talked with Luis Falcon and also with other people that they are trying to see what's going on. Either we have two different courses, they put you in different courses, probably. That's why you're not appearing here, or they put me in the wrong courses. So anyway, they will fix this issue. So if you don't see anything, don't panic. It's not, there's nothing here, okay? There's just 4 links, and I'm going to share with you these 4 links, okay? So it's where, as I said, like if you remember the distributed system course, the first day of the class, I had everything ready, right? All the activities were ready, project were ready, reading were ready, assignments, but this is different. There are just 4 links ready. But let's start. This is okay, so can you see my screen?
Yes, it says
Yeah.
Okay.
Yep.
Perfect. Just let me adjust. I want to see the screen. I want to see you at the same time. So let's see if I can do. Okay, welcome again officially to the cloud computing course. So this is the first lecture. I mean, for Ricardo, that he's the only one that doesn't know me. This is my name. I'm Mahdi Zareh. I'm originally from Iran. I've been here in this school last 5 years. Okay, 2 years as a postdoctoral researcher and 3 years as a research professor. And I do research on information security, telecommunication, 5G, security in telecommunications, security in IoT, security in stuff, a wide range of basically topics I touch actually, because most of the things comes from basically my collaborative network. That's why I collaborate with them. So it's a wide range of topic, as you can see. That's all from me. Okay, but I don't know. Do you have any question, Ricardo?
Nope, nothing just yet.
Because I'm saying that I'm just asking you because everyone else. I already talked this to everyone else, so they know me.
Yeah, I know you're not singling me out just because.
So, okay. So I thought there were going to be more new students, but they are not. So I want you guys to introduce yourself, okay, briefly, because again, I know some of you, I mean, most of you, almost all of you, and I remember what you were doing, more or less, not so exactly. So briefly, I want you to introduce yourself because I need this later on, and I want everyone to listen to everyone's talk, because later we're going to do the grouping. We're going to do activities in the groups, and it's really important you realize who is taking this course. So let's go. It's going to be complicated here. Let's go with Pedro, as I'm seeing like in the order of what I see here.
Okay. Well, my name is Pedro Cortés. I'm from Sinaloa, from a small town that is called Palmillas, but I have lived here in Guadalajara for like 17 years. I work in Oracle like a release manager, and my thesis topic is security of the information in smart contracts. How you can protect your information in the smart contracts. Like you see, smart contracts are some kind of blockchains, and most of the blockchains are publics. So most of the information can be seen in those kind of contracts. So what we are doing is working with a tool that is in some kind of role playing. So some roles can see some information and some others cannot. How much experience do I have with cloud computing? Well, as I work with cloud computing more like a user than like an administrator or something like that.
Okay, thanks, Petro. It's quite interesting
You're welcome.
topics you're working on. Jose Antonio? Yeah, let's go with you.
Me?
Yeah.
Okay. I'm Jose Antonio.
Oh, sorry, yeah,
Thank
you
you.
have two, sorry. Yeah, Gutierrez.
I'm working at Oracle. I've been there like 9 years. And I'm from Michoacán, Uruapan, Michoacán. And my thesis is regarding software-defined networks, how to use them to improve the security of the edge layer
Mhm.
in IoT. I'm not sure what else should I say.
Any experience with cloud computing?
Not really much experience.
Not much. Okay. Great. Thanks, Jose. Let's go with Brian Campos. You're muted, I guess.
Hey guys, well, my name is Brian. I'm from Mazatlán, Sinaloa. Well, right now I work for Charter Communications here in Denver, United States. I have here like 5 months. I was living in Guadalajara for 4 years and a half. And well, my thesis is about developing an IoT device with the ability to alert authorities about fires early. Right now we're working with 5 sensors, and we continue the research, and the idea is to present the thesis by the end of the year. And I don't have much experience with cloud computing.
Okay, thanks, Brian. Let's go with Juan Carlos Diaz.
Hi everyone. My name is Juan Carlos. Everyone calls me Charlie. I'm from Aguascalientes, Mexico. I work at Oracle, and my thesis is about software quality management process to reduce the bugs backlog and improve the code quality in the team for which I work. And I don't have a lot of experience with cloud computing. All I know is basically what I learned in your previous class.
Okay, perfect. Thanks, Juan. Let's go with Javier.
Hi everyone. Well, my name is Javier Alejandro Torres. I'm from Guadalajara, Jalisco. I'm currently working for Intel as cloud software engineer. And well, my thesis topic is about machine learning for the detection of heart attacks. People from 50 to 60 years. Well, how much experience do I have with cloud computing? Well, basically, I work as cloud software engineer. Maybe I will say that the 10 months. I need to say that the distributed system class that I take with Maddie helped me to get that job. So I check things like load balancers and more things about the software and hardware perspective. So yeah, that's
Awesome.
me.
Awesome. Thanks, Javier. Let's go with David Orzoa.
Yes. My name is David Ursula. I am from here, Jalisco, in Guadalajara. And I am a software testing engineer, developing tools for test automotive modules. And my thesis topic is deep learning applied to detect cancer cells in cervix pathology samples. And my experience in cloud computer, it's limited to the master. It's only classes. Yep.
Yeah, thanks, David. I'm putting some keywords here as you're talking. That's what I'm doing. Okay. So later we can discuss about it. Thanks, David. Let's go with Luis Montes.
Hey everyone, good morning, good afternoon. I'm Luis. I'm also from here, from Guadalajara, Jalisco. I work at 5 as a software engineer, and my thesis topic is trying to implement CI/CD pipeline and DevOps like ideas to one application that does not support CI/CD like natively. So that's my thesis topic, and how much time we can save with the pipeline. And I don't have much experience with cloud computing, just some courses, but yeah, it is almost none.
Okay, thanks, Luis. Let's go with Ricardo Rey.
Hey, yeah, so my name is Ricardo Rey. I'm from Guadalajara, born and raised. All of my life I've been living here. What do you do? As in for fun, I used to play video games, but now I take care of my 2-year-old son. So now there's not much time for video games. As in for work, a lifetime ago, I used to work at Oracle with some of these guys. Then I worked at Facebook for a while, and now I work at a startup called Cyril. We work in cloud security for databases, but I actually don't know a whole lot about cloud computing. I know I hate dealing with AWS. I can never find the logs I need, and I can never find anything in AWS. But Kubernetes is quite friendly, and K9s is my favorite tool ever. So that's pretty much all I know about cloud. My thesis topic, I do not have a thesis topic yet. I kind of dropped this master's like 5 years ago and just restarted it like 2 months ago. So I still have like a few courses to take before having to do my thesis. And yeah, my cloud computing experience is poking the DevOps team in my company to tell them that things don't work and get them to help me out.
Okay, Ricardo. Thanks. But you said you took the distributed system course, but long ago, right? A long time ago.
Yeah, and it sucked. I thought we're gonna like study Paxos and Raft and all that stuff, and in the end, it was just making small diagrams of how one service would call another. But we didn't actually do any coding or anything. It was literally like one of the worst classes I've ever taken. So yeah, I mean, I know what Paxos is, I know what Raft is, and not thanks to that class.
Okay, but you know them, so it's good. Great.
Yeah. I mean, I actually don't know how they work. I know what they are used for, but yeah, besides that, yeah.
Okay, great. Great, thanks, Ricardo. Let's go with Hugo Rodriguez. He just dropped, I think, out of the chat. Oscar, let's go with you. Oscar Gallegos.
Okay. Yeah. Hi, my name is Oscar Gallegos. I'm from Aguascalientes. I used to live in Guadalajara, but since I've been here in I got back to Aguascalientes like 7-8 months ago. So the plan is to go back eventually to Guadalajara just once that the office says that we should go back. I work at Oracle. I've been there for 6 years. I work in database as a service, which is cloud related, but developing for cloud not always means that you interact with it from administrator perspective, per se, like that way. I know exactly what is going on in my VM, but from outside and how everything interacts, it's not that clear to me. Cloud is not something that I, well, besides the VM that I work with, that I usually interact with. And what related to the thesis, I still have to discuss some stuff with my assessor, but it's related to optimization of home security using genetic algorithms. But I mean, it's still, we still need to define some stuff.
Okay.
And besides that, well, I think that that is everything that I have to share with you. Thank you.
Okay, thanks, Oscar. But you're in the you also have just one more year, right?
Yeah, 6 months when you're your is still pending. Mhm.
Okay, perfect. Thanks, Oscar. Let's go with Alejandro.
Hello, my name is Alejandra. I'm from Sonora. I'm a web engineer at Oracle. And my thesis topic is machine learning to predict sales in my using the database of my own business. And how much experience do you have? I only have the experience of that I took in your class, the last class. And that's all. And the things that I heard in my work, it's the only experience that I have.
Okay, great, Alejandro. So I see a lot of machine learning people here. I mean, as
Yes.
expected. It's great. Let's go with Fernando.
Hi guys, my name is Fernanda Guzman. I'm from Mexico, specifically from Torreon, Coahuila, but I just lived there like 1 year of my life. The rest I live in Tijuana and then in Guadalajara. I'm currently working at Microsoft as a user experience designer in the xCloud team. It's the service from streaming video games in any device by Xbox. And my thesis topic is going to be automatic remapping for controlling using computer vision. And how much experience do I have in computer cloud? Nothing really. This is my first time. I once took a class of Docker, but it was just for curiosity and that's all. Yeah, hello.
Okay, thanks very much. You said your topic is related to computer vision, but I didn't get it exactly.
Remapping controllers. Since Xbox, it's currently has this service that you can streaming video games in any device. You can also bring any controller, not even Xbox controller. So I want it to be easier to remap. So I want to use computer vision for this purpose.
Okay, cool. Okay, that's great. Thanks, Fernanda. Let's go with Saul Lopez.
Hi, my name is Saul. I'm from Oaxaca City. I'm currently work at Oracle, but my apologies for my setup.
No worries. You're in the back seat, right? You're not driving.
Yes.
Okay.
Yeah, I'm currently in Mexico City. So, well, anyway, my thesis topic, it's about, well, my current thesis topic is about contextual search. I know that I have contacted Mari a few weeks ago because I wanted to talk about distributed systems, but due to some work restrictions, and I had the opportunity to use my work for implement my thesis, so I had to change my topic thesis. So I'm currently work on a contextual search. I want to take advantage of the data that we possess in our team. So we want to provide the users a better result about what they are looking for. So we don't want just to provide a plain result. If they are looking for payments or raise, we don't want to provide the match about the words. We just want to provide more context about what they are trying to look. And my experience is I took the distributed system course. I have taken some courses with Falcon. So yeah, I hope to be in a good shape for my thesis.
Okay. Okay, great. Yeah. Great. Thanks. Safe trip. So let's go with Paul Mejia.
Hi, my name is Paul Mejia. I'm from a small town 2 hours from here in Nayarit. I'm currently working at Intel as a power and performance hardware validation engineer. I am more focused on the hardware part, but I need to also develop some scripts to for the automation of the work and the data we collect. Currently, I don't have a thesis topic because I moved to a new group recently, last March, and I would like to merge my thesis topic with a kind of innovation tool for my work, my current work. And it is possible because the school and Intel have this agreement, NDA. So it is possible. So I am in the time frame that what I need to think about it and took a topic. And I have 0 to none experience with cloud computing.
Okay, thanks, Paul.
Yeah.
Let's go with Christian Alejandro.
Hello. Well, as you said, I'm Christian. You can call me just Chris. I was born in Mexico City, but most of my life I used to be in Aguascalientes. Then I've been like 6 years in Guadalajara since I started working for Oracle as QA engineer. And my thesis topic is related to one improvement for the current triage process. It is to select the best available resource from the development team based on history, recent bugs, closure, and some other statistics, which is part of the work to identify which of these variables are like the best to select the candidate on the triage, just to save some time and effort for the customer. And regarding the cloud computing, as some already mentioned, it is just, for me, just theory, nothing practical on that I'm new. And also from as customer consuming from any of the common services from any applications on mobile, like for apps or some other streaming.
Okay, thanks, Christian. I mean, people are turning off camera, turning on, so everything is like messed up. So I try to remember who didn't present. Hugo Rodriguez, I think you didn't present yourself. We don't have your voice. No. So meanwhile, let's go with Gutierrez.
Hello.
While you're yeah, I can hear you. I mean, Hugo, you can try later. I get back to you later. Okay. Yeah, go ahead.
Thank you. Well, my name Gautier Ortiz, and I am born in Durango. But most of my life I have living here in Guadalajara since I was about 6 or 7 years old. What I do is I am currently a channel account manager for Hewlett Packard Enterprise. My thesis topic it's about API or API. In order to create an interface between some of our arguments and Canonical, we have a large end user and they want to use a free software in order to get their objectives or something like that. And well, this interface is not developed, so I am trying to work on that. And experience with cloud computing. Well, I don't know. Well, I sell equipment for the cloud. In fact, for private cloud, I don't know if I can call it experience. And well, I would like to know what our customers or end users do with all this equipment in the cloud. So I I am eager to have to have this class in order to find out about that. I don't know much about cloud computing because my current position is a commercial one. And well, the ones who have the details and everything about bits and bytes are the infrastructure architect or solution architects. So I am, as I said, I am eager to have this class in order to find out what is the cloud computing.
Okay, perfect. Got here. Thanks for the introduction. Now we can go with you.
Okay, can you hear me now?
Yeah.
Okay, cool. Well, hey everyone, my name is Hugo Rodriguez. I'm from San Luis Potosí City. Actually, I'm a Java developer at Globant, but also I am starting a new job as a teacher of computer architecture course on the local public university. And well, my thesis topic is not existent because I'm not there yet. So, and I'm not sure what I'm going to do about that. I'm interested in things of like software engineering or something related to hardware or stuff. And the experience I have with cloud computer is much related to basic usage. I know that we are deploying on Kubernetes using Docker containers, orchestrating all those things. I have been working on that a bit on that as well, but not much besides that. So yeah, that's what I have.
Okay, thanks, Hugo. Let's go with Juan Antonio del Cuellar de la Peña. Sorry if I'm not pronouncing it right.
Yeah, no problem. It's Cuellar de la Peña. No problem. I understand.
Cuellar.
Hello, guys. How you been recently?
It's good.
Cuellar. Yeah.
Okay.
Sorry, I'm having a lot of trouble here with my connection. So if something's wrong, please tell me. Well, I was born here at Guadalajara. Currently, I work as electronic board repair manager at Foxconn company. My thesis topic is emotion recognition using deep learning, basically. And my experience with cloud computing is none. So I hope I can learn a lot in this course.
Okay, thanks, Juan. It's you said emotion detection in what, video, text, or what? Images?
Well, those are patterns, and I think I will use TensorFlow, which I think is kind of complicated. But well, I'm just studying hard to get on with the work.
Okay.
Yeah, because it's really extensive. Really extensive.
I understand. Okay, thanks, Juan. Let's go with Paul. Paul Gallegos. Yeah. You.
I was not sure.
Yeah. You are the one.
Yeah, because when you said Paul, I was going to talk before, and it was not.
Yeah, sorry.
It was Paul. So yeah, my name is Paul Gallegos. I am from Guadalajara, but I live in San Diego. What do? I'm an automation engineer. I work mainly on automation for analytics. And what is my thesis topic about? My thesis topic about is web system architecture using open source and freemium, libraries and tools. And how much experience do I have in cloud computing? I have more or less experience. I have used a bit of Google Cloud Platform and AWS, and currently I support once in a while the infrastructure and DevOps team. And I have been using also Kubernetes, Docker Compose, and Docker, and things like that. But either way, like there's still a lot to learn. I've been using it only like for 2 years. So, and that's why my thesis I'm making it about scalable systems, because I want to learn more. And that's why I took this class. I'm taking this class.
Okay, awesome. Thanks, Paul. Let's go with Rodrigo. Let's go with you. Sorry.
Yeah, don't worry. So hi everyone.
Change stuff.
Yeah. Can you hear me?
Yeah.
Right. Yeah, sorry, so it's the computer. I just can't get the micro working. So my name is Rodrigo. Where am I from? I am from Mexico City. I have always lived in Mexico City. What I do, I currently work at Autodesk. I mean, I guess every time that I get into a new class, I get a new job. I just hope to keep on this one for a little longer. What I do there, I'm a software engineer. Currently, we are making a distributed system, you could say, with some machine learning there to basically make water consumption in water plants smarter. And we have like an event-driven architecture, and well, it's just right now a mess, but it is working. What is my thesis topic? My previous thesis topic, or I could say that my current thesis topic is more related to how I can guide decisions on serverless and how they oppose onto like the server-aware implementation of stuff. I am just like a little discussion right now because I was just introduced into a topic that is about natural language processing to generate code automatically. And I mean, it just like blew my mind. So I'm just like a little just excited on that one yet. How much experience do I have in cloud computing? I mean, like, I guess tons. I've been working like with Ali Cloud and with I don't know, with AWS, with GCP, with Azure, and with everything, doing some architectures here and there. Some of them are working, some of them didn't. So yeah, I mean, I have done some.
Okay, great. Thanks for the. That's changing job is a good thing, right? I mean, or should I feel bad?
Yeah, well, it is sometimes it is a good thing when you're changing job because the company didn't close or didn't work, but when it is because of that, then it's not that good.
Okay.
Yeah.
Okay, great. Let's go with Manuel Carrera.
Yeah, sure. Can you hear me?
Yeah. Sorry, I forgot to pin the face.
Okay, perfect. So, well, hello everyone. My name is Manuel Carrera. Right now, what is the next question? Where are you from? Well, I used to live in Mexico City for a lot of time, but right now I am living in Puebla. What do you do? Right now I am working at EPAM System as a data engineer. I am working with a lot of different architectures, but my favorite technologies are Spark, Apache Beam, Apache Kafka. So I work a lot with these different resources. I don't right now. I don't have any topic, but I would like to work with something related with distributed systems. For example, I would like to create this kind of methodology where you can define the right cluster site in your Spark project, because right now it's like a little bit hard. So probably that can be a good topic. And how much experience? I have been working with GCP and Azure for like the 2 last years, but I prefer GCP. So, well, that's it.
Okay. Okay, thanks, Manuel. Anyone I skip or anyone? Did I go with everyone? Because I mean, turn on camera, so everything is shuffled. So I think anyone didn't introduce himself or herself? No? Okay. So thanks you all. I mean, it's interesting how you respond. It's like, oh, I don't have much experience, but I worked like 2 years on this. I'm like, well, you know a lot. Okay, most of you have a good amount of knowledge, I assume. And this is my note actually. It's like what they're talking about. These people. It's like I don't understand their topics and their research and the job. So actually. Anyway, I'm going to talk about it. Okay, so let's see what we have here. So about the course structure, I want to talk to you. So as I emailed you about basically how I'm thinking to manage this course. I'm thinking to manage it research-based course. Okay, so we're going to define certain things right today. Okay, right, with you negotiating, fighting, for making it easier or harder, okay? So you'll see how it ends. So what I mean by research-based course is, I mean like this. So this would be something like class format. So what I'm thinking of is to setting a lot of papers actually, okay, by me, selected by me, about different topics in cloud computing. And then the idea is basically we all read the paper, okay? And one student basically does the present. I mean, for Ricardo, he's the only one didn't took the course with me. This is the actually common practice. We did this exactly with the distributed system, but it was a lighter version. Not everyone was reading the papers, though they were supposed to. But this time it's different. It's I'm assuming to make it like we all read the papers ahead of the time, but one student present the paper and another student lead the discussion. But what I mean by this, basically two students read the paper 3-4 times. The rest of the students read the paper 1-2 times. So because the student that's presenting need to have a better preparation, the student that going to lead the discussion needs to also understand the topic much better than the others. So we can come to the class, hear the presentation, something around 30 minutes, have like 15 minutes basically discussion on the topic, okay, but participating everyone, and then maybe having short break, then going with the second one. So like I'm thinking to have like 2 paper per session. I'm going to tell you a little bit more about, then we can fight and see what we will end up with, okay? How to manage the course. Because again, as I said, it was basically a surprise things, and I'm basically came as unplanned, really, a little bit, not a lot. And now I put one student's take note is like one student's also I put responsible to taking notes of the discussion, the important points. So later on, everyone can have the notes. Then I am thinking to invite certain people to give talk from the industry. You'll see that one. Then, but anyway, just here. Any comments? Any suggestion? Any complaint?
So this is going to be in Teams?
No.
I suppose that it's going to be a team with 3 students, and 1 student is going to be something like that, or?
It can happen like that, but at the end, the student that's going to prepare the presentation is going to be, I assume we're going to work mostly alone, okay? So that's why I'm not making this a team activity. So everyone's reading. The one that is preparing the presentation, most probably going to read 4 or 5 times, because it's by reading 1 time, you don't really get to understand the paper to talk about it. So you need to read more. And if you want to lead the discussion, you need also to understand the paper pretty well, right? So I would say the first student put the most of the effort, the second student less than that, maybe half of that, and the other student, they would just maybe read it 1-2 times to understand the paper, to have some idea about the paper. So when we come to the class, so we can have some constructive discussion.
So each
each student is going to take at least once in the course,
Yeah.
one of the profiles there?
Yeah.
Okay.
So I'm putting this because the grading activities I'm supposing to be like this, like Rodrigo is quite happy. So there wouldn't be any quizzes. We had 3 quizzes in the distributed system course, no written assignment. We had 3 written assignment in distributed system course, no partial exam we didn't have in distributed system. No projects because we have 3 big projects, you know, it was a lot of you were suffering a lot actually with the project, and also no final exam. So no grading activities like this.
I have a question from the previous slides about the leading.
Sure.
The discussion. About the leading the discussion, what do you expect on the leading part? Like only handling like, let's talk about the performance of this tool, or let's talk about the usage, implementation, configuration details, or I honestly don't know.
Yeah,
What
the
do you
leading by leading discussion, I mean, basically I wanted to. Actually, I was, if you remember, in the distributed system course, we had 2 students presenting, and I was having this basically feeling that for some of the presentation that one didn't catch completely the idea of the paper, one is totally understood it, and like, you know, so this time I say, so I want both to understand the paper pretty well, so one can present and another one can help with the discussion. Basically, the presenting a student, I mean, let's say you're presenting a topic about how to scale in cloud computing, okay? Then, of course, there would be question from listener, for students, other students. So this presenting students, of course, supposed to answer the student that lead the discussion also supposed to help answering the question, leading the discussion. So basically, the idea is like helping the presenting students to answer the question, and also add more to the discussion.
Okay.
Something like this.
Okay, I think that I will get a better idea after the first one.
Yeah, like, yeah, basically you can say like 2 students, one is presenting, one helping him or her to answer the question. Not just a question, but also to because we want to have discussions, not just question answer, because in the distributed system course, I mean, after presentation, we're saying, okay, any question? There wasn't many. Usually it would come just 1, 2, or 0, right? So this one, I want to have more discussion because I want everyone to read the paper, really.
Okay. And invited speakers, what is invited speakers again?
By invited speaker, I mean, probably because we don't have, if you remember, like in the distributed system course, we had 3 project presentations, right? And I was thinking in those sessions, okay, so I can hopefully find someone from industry to come and give us the talk, or from other universities or from industry. You know, that's what I mean by invite speaker, not from students. But this is, I mean, of course, if I can find someone that fit this time.
It says one student takes notes. You mean at the end of the semester we need to prepare something, or?
No, I mean one student take note, but I mean about the discussion only. Maybe something interesting come up in the discussion, so I want to have, like, it's like a meeting, you know, like when you participate in a meeting, one person takes a note. Who is asking about, who is bringing this this question up, who is basically making comments, you know, what comments made, something like that.
Okay, understood.
Question, doubt?
The format to present the paper, it's by choose.
Yeah,
it's
free
choose
format.
by the alum. Yeah, okay.
Yeah, any way. Other comments? Anyone feel uncomfortable reading paper? Presenting papers? Talking about them?
Professor, I just have one question.
Go ahead.
In those papers, there will be like there will be a link between cloud computing and I don't know, machine learning topics, deep learning topics, or
yeah, actually, I mean, I'm trying to pick the papers. I have a short list of a few paper. I'm still honestly checking them. I mean, it's not like just to be totally clear, it's not like I read the paper before or I read most of them. Not really. I'm going to read them too. Okay, with you. Okay. So we're going to read all of us. We're going to read together. So some of them are maybe key. I know them. I read them before, but mostly probably not. Okay. So we are all going to read, and I'm trying to basically pick papers that. I mean, at least for the beginning, there are some introductory papers. Later on, maybe at the middle of semester, some applications. So maybe at the end, some more advanced papers. Okay. So I'm checking it still. I just picked 4. I'm going to talk about those 4 with you today. That are basically for the next week.
Okay, no problem.
So this is just one activity, okay? That we are planning to do. This is for the class. And of course, it's a grading activity. So I have some tips and tricks. I mean, how to basically what to look for when you're reading a paper. Okay. So basically, these are the things I want to be highlighted in your presentation. The challenges that is addressed by the paper. What's paper trying to basically address? What type of challenges people are trying to address? But not all of them are trying to address a certain challenge. Some of them might be a review paper on a topic. Okay. So the key insight and original contribution of the paper. This is the one I'm pretty sure I clearly remember we were talking in the distributed system course. I wanted you to highlight this very clearly, but that's I mean, if you don't get it from the paper, it means you didn't read it properly. So critics, I mean, of course, it's very important. I mean, when you read the paper, you have to have some critics. The major strength and the weakness of the paper that you're reading. You say, okay, this paper is really addressed this question very well, but they just didn't touch these things. So look at the claims and assumption, the methodology that's used in the paper. Not again, all of them are like this, okay? But because some of them are like review papers. Then future work in the paper, like what they talk and what are basically open issues that they are raising in the paper. So for example, can we apply the methodology to other problems? What are the broader implications of the basically solution they are suggesting, or any open research basically they are proposing for the future work? So just things that to remember for when you're presenting a paper and then you're reading them. And tips for reading, you can read the abstract, intro, and conclusion first. This is a good things to do. I mean, when you're reading in any academic paper, go abstract. I would say I would mostly highlight like abstract and conclusion, but introduction is important too. Read these things first, okay? Read the rest of the paper twice, because you understand now abstract is just a paragraph, the conclusion is just a paragraph. Then you can read the rest of the paper twice in order to understand it better. Underline, highlight the importance of highlight the important parts of the paper. Keep notes on the margin about issues, questions. All these things helps you to prepare the better presentation when you're reading. It's not like you read and you come and you say, okay, now I want to prepare something. It would be good to keep notes while you're reading. And another things that is good. I mean, this can be. I hope this can be helpful for you, not just for the course, for the whole things, I mean, for all your research life. Okay, till you finish the master. Hopefully, if you join academia to do PhD later on, so this can help you. So you can look up references that seems too important or missing in the paper. And you may also want to check who references this paper and how. So for example, you're reading a paper and the paper has like, I don't know, 10, 20, 1500 citation. It would be good to check a few of them and see why they are referring to this paper. What other researchers are highlighting about this paper, why they are citing this paper. That can help you also to understand the paper. Okay. So these are just tips about reading, nothing about grading and course. Question? No. Okay. So as I said, the grading activities, there will be no these things, these activities, but their question would be then how the grading, how I'm going to grade, right? So the devil is in the details. So this is the what I'm thinking. I'm totally open for discussion and basically a suggestion. So I'm thinking the paper presentation comes to contribute 30% to your final grade. I'm talking about the final grade, okay? Because the partial one I can calculate somehow, put a grade there. It's not a really big deal there, but the partial grade is important. So I'm considering paper presentation 30%. Because there would be 2 paper presentation per student and also 2 as a basically discussion leader. So I'm thinking, I'm sorry, Ricardo, you said you hate AWS. Okay, I'm thinking AWS has online course. Let me show you what I mean by this. There is this awseducate.com from Amazon AWS. So when you go there, there's actually a lot of courses there. Depend on what you want to basically learn about AWS. So actually, the idea is here to give you freedom to pick a topic that you find more, basically you find it interesting. Based on your job, based on your thesis, based on your interests, whatever you want, okay? So I'm thinking you can, I was just getting inside and just check what is it, how it works. Basically, you can pick any course. There are the hours here, okay? For example, you can just go with this one and this 35 hours course. 35 hours is like you hear some lecture, you read some basically document, that's it, okay? It's like estimation, like it takes 35 hours. So what I'm thinking with this is to ask you to take 30 hours course, anything you want from this, from AWS, okay? So you can go here, you can put whatever you want, advanced courses only, because you know a lot, so you can go with that. If you don't know anything, you wanna go with intermediate course, your choice, or you wanna go with some foundational. Question, comments?
Yeah, what will be the difference if I choose beginner or intermediate or an advanced course? I think that there will be differences because the differences in hours is huge from 2 to 35, for example.
No, there wouldn't be. I mean, to me, it's the same thing. I mean, so some of you have more experience, so you say, like, why should I waste my time doing this one while I know it? So I want to pick something and learn something, you know. So now it doesn't matter for me. You can go with the level you want, or with any topic that you feel necessary for you to learn, or you feel interested.
How many hours?
30 hours.
30 at least?
Yeah.
Okay.
I mean,
so this is kind of mix and match 30 hours course topics. You can mix and match topics for 30 hours.
Yeah, of course. Yeah, of course. Yeah. That's why. I mean, maybe you wanna. I mean, these are. Let's see. Let's put like intermediate. Maybe you wanna pick this 15 hours, mix it with this 10 and 6 hours, because you find that interesting.
Maddie, I have a question. And how you will know that we already took the course? Or
Yeah. The deliverable would be basically your account, making sure you pass the course and you finish it, because it keeps track of your activities. It shows the progress.
But we have like a license, or
Yeah,
we
this
have
is
to
free.
buy it.
No, this is free.
Okay.
Yeah, but the problem is that you can just run the video and that's all.
So you mean, how can I verify that you took the 30 hours?
Yeah, because I
and I
can let
guess,
the video run like for
Yeah,
one
you
or
can
3
do that.
hours.
You can do that. If you don't wanna, if you don't wanna really read anything and you wanna like put 30 hours video there, like waste maybe electricity, you can do that.
yeah, I guess if you want to learn, you will learn. If you don't, then I guess you won't, right? Like,
Yeah, that's
that's
really
true.
yeah, that's true. I mean, there is really, at the end, there isn't any way for me to monitor basically all the activities. So this is for me to encourage / force you to spend like 30 hours on this. If you don't want, then it's okay.
Okay.
Don't do it the right way. But I think you would do. I assume you would find really interesting things here based on your. I mean, I was asking actually this thing that I'm going to tell you. That's the part about it. I think you will find interesting thing here. But in parentheses, if you feel there is better things out there worth your time about cloud computing, I'm totally open for replacement. You say, I don't, for example, Ricardo say, I hate this. I don't want to even just see it. I don't want to deal with AWS anymore. I find something more interesting. It's, can I replace it? I'm totally open. I'm totally fine with that.
Okay, thank you.
So I don't want to force you to do AWS, but I want to force you to go through one of these things. There are a lot of things probably I'm not even aware of, okay, about different technologies, courses, online courses. So you can pick anything you are interested about. You can tell me, okay, this is what I'm thinking to replace with AWS part. I'm totally open for that. And it's totally fine.
Okay, thank you, Mari.
Mari, and we can take like different courses. For example, if one is of 5 hours and the other of 10 hours.
Yeah.
Okay.
Yeah, but again, as I said, don't feel this is where you're limited to. If you, I don't know, there something out there in another platform about Microsoft, about any other system that providing this type of services and courses, feel free, email me. You say, okay, this is the one I'm gonna do. Okay. So I want to give you this freedom about this because I assume based on your job, thesis, and interest, you would have a really diverse interest about this. So you can go with your interest, and you don't need to basically. I don't want to force you to just go with this and pick this course because again, it's a vast topic, a lot of knowledge. So you can
In the case for Oracle. In the case for Oracle, we can take any OCI course?
Yeah, definitely.
Okay, thank you.
Yeah.
Does it have to be like an official source? For example, in the case of AWS, well, we have this page, right? But can we take any course like Udemy or Coursera or? Okay.
Yeah, definitely. Yeah, I'm totally fine with that.
But it has to be related to cloud computing, or can be any technology topic.
No, preferably.
For example,
go ahead.
I don't know something about coding, but not directly related to. I don't know. I am just thinking. For example, a Python course, something like that.
No. I mean, no, preferably, no, not preferably. Definitely related to cloud computing.
It has to be related to cloud computing. Okay.
Yeah. Cloud computing, distributed system, grid computing, parallel computing. I mean, all this comes. I'm going to discuss all these different terms, but more or less they are falling under same general umbrella. Question?
Can you share the link in the chat so I can
Yep.
so we can have it? Thank you.
Yeah, thanks for reminding because you don't have access. So, any question? How do you feel so far? 30% paper presentation, 20% discourse. It's fair? Or
I think it's great.
okay. So what about the last 50%? This is also open for discussion. So I actually on that email, that shocking email that I received about the course, I realized that basically no, I'm seeing it. Most of you are the final year, okay? Most of you, not all of you, but most of you are the final year. You have one more year. Basically, you are. I assume most of you are already took thesis one course. So another activity I was thinking to do was writing a review paper on different topics related to cloud computing. And here, my idea is to form a group of 3 students. We have 21 students officially in the course, okay? So we can have group of, basically 7 group of 3 students and collaboratively try to write a review paper. What do you think about this? Review paper, basically what I mean, like reading different papers on the different topics on cloud computing and trying to write, coming up with a draft of review paper by end of the semester.
But like in general of one paper, what it's about this review paper?
Review paper is a paper that summarizes, basically a paper that summarizes the part of basically one area in, I don't know, like a review on serverless architecture.
Okay.
A review on quantum computing and cloud computing. Quantum as a server, quantum computing as a server, as a service part, sorry.
Okay, but you want the paper.
Or security in cloud computing.
You want the sources. You want to have like some kind of intro. Some kind of like if you are presenting. Obviously, it's not like a real paper because we are not doing our own data, or we are not getting our own discovery, but we are just like talking about a topic, and we need to present like it was like the result of our investigation or our research.
Okay. Anyone is published author here? Conference paper, journal paper?
Everybody what?
Anyone have ever published academic paper?
Long time ago.
Who said that? I didn't hear. I didn't see.
That was Paul.
So you mean like the papers called survey? Survey about a specific topic?
No, any academic paper.
So yeah, I wrote 2 of them when I was working at Continental Automotive. That it was for embedded systems about recognition of flat tires, for example.
Okay.
And yeah, and it was presented in but it was normal because it was required always to make patents, and you have to write like a paper for that.
Okay.
And then you can use it for some conferences for automotive, but those belong to Continental.
Okay, yeah, I still understand. But just in general, anyone in here have interest in writing papers at all?
I'm sorry?
You're not required to write paper for your graduation, no?
No, nobody.
No?
But we can learn, don't worry. We're okay.
No, I don't want to force you to do something that it won't basically value. It won't add any value to your study. So there is no requirement for you to publish a conference paper to graduate.
No.
And then no one, I assume, is interested in academia and like want a paper in their CV. Why to have a paper?
Yeah, I don't think that somebody is that interested in academia. I
You
think
don't
that
have extra value here in Mexico unless you are working for a university.
Yeah. Okay. So forget that 50%. You are all failing.
You're
No,
failing.
No, it's
We are all in trouble.
I should think of something, some activities for them.
I mean,
No, because the
I mean-
writing it's not easy. It's that's why I put the most heaviest weight on that, because it's not an easy activity. So and if there is no interest, so I assume there is no really, there wouldn't be anything good coming out of it at the end. So no point.
I mean, if it's not a paper, I always like to do like my notes of my class, like for myself in the future. So it could be like a summary of your own notes or something like that if it's not a paper.
A summary of
I
the other papers, right? Yeah, that's
of your own notes, like what did you learn or something like that if it's not a paper, because I also don't know how to write a good paper for internet, but for my notes, well, for my own knowledge, it's okay.
Yeah, okay. No, I mean, we can put some project there. I mean, the project that you can come up with related to the, or I can come up with related to the cloud.
yeah, everybody has to build a system.
Huh?
Everybody has to build a web system.
Yeah, something like that, like like the distributed system course. So ignore this one till further notice. Okay. All good? Are you
Okay.
happy about this 50%? You feel fair?
Yes.
Yeah. Yes.
Yes.
Okay. So I'll update you with this one later on, okay? So probably the weight is still the same, stays the same, and this one would be probably breaking up to different activities. So, but again, as I mentioned in my email, I don't have any plan to make it as heavy as distributed system course, okay? So it won't be really time-consuming activities, but it would be anything like that would cover some weight like this, okay? That if this time like 30 hours here, probably 20 hours here, or 30 hours here, or more probably. Here it would worth 50% of the course valued of the grade, then this 50% should be basically on the same scale, okay? Okay. Let's have 10 minutes break so you can refresh, drink some water, and we come back. Anyway, I'm almost done with the structure of the course. Then what I'm planning to do is have a short talk on background on the basically cloud computing, like the first course, first class for distributed system, and we went through the background and concept and like this. So I'm going to talk a little bit about that. So we can come back by 8 p.m. Okay, and we continue.
Okay.
Sounds good.
Okay.
What time are we returning?
So what we were discussing is the activities. So this is the one that's canceled. Ignore it for now. So the idea with the presentation, this is the breakdown of the grading. So the idea is basically that to have 2 paper presentation per students and 2 basically leading discussion. So this will contribute 30%. All good?
All good.
I try to solve those problem with the Canvas as soon as possible, so you can have access to these things, the links and the slide But I'll tell you, I mean, I already made a Google Drive to share it with you while you don't have access to that, so you can access to the files and everything. Yeah. So any doubts for now?
Nope.
All good?
Yeah.
Good.
Okay, so let's continue.
Yes, I have a question. You just showed the new rating?
This one?
Yes.
This is the same thing. I just break up to more detail,
Okay.
but the total is the same.
Okay. The other 50% is still not defined. Okay.
Yeah, I will come up with something. Hopefully, it's something interesting. Okay. So, no question? So let's continue. So let's have a quick overview of cloud computing. Okay, background overview, and as I put here, some of the slides are partially borrowed from courses from these universities. Okay. So, I mean, when we're talking about computing, I mean, if you Google it, you see a lot of different concepts. Okay, for example, you put grid computing versus cloud computing. What is grid computing? What is cluster computing? What is distributed computing? What is utility computing? What is parallel computing? Okay, so let's talk about this. Let's define these things. Let's see how we basically how we get to cloud computing as a concept. Okay, how basically a little bit about history. Okay. So we understand and we appreciate basically the advancement, let's say, on the field. Okay. So let's go back to talk about a little bit generation of the computer system. So it's not really an official category. Okay, I'm not claiming this is the right way to break up basically generation of computer system, but we can look at it something like this. Okay. Till 1904, we have basically electromechanical calculating machines, big, giant, bulky devices that mainly they were not really electro, but mainly mechanical devices. From 40 to 55, you start basically developing electron tubes, back panels, and stuff like that. Then after that, we moved to, let's say in second generation, we moved to transistors and processing, batch processing. And after that, generation 3, if we can call it, okay, we basically invented integrated circuits. Then in generation 4 was basically the generation of microprocessors. We can call it workstation, PCs, large scale integration. And let's say that we can call it from basically 1980 to 2000. And from 2005 till current basically time, we can call that basically the 5th generation of computer system, where we are talking about distributed system mainly. Okay, where basically the network is the computer itself. And I think these are the technical progress or technical terms that dealing a lot with that 5th generation. So basically what we are focusing now is this one, right? The 5th generation. We want to discuss this one, okay? So in the 5th generation, some of the keywords we can consider this. The network is the computer. What I mean is, basically you can look at all the network, all the connected system together as a whole computer, and we can something like what we were discussing in distributed system. We can look at it as a whole system and we can deal with it. We can use that power. So then another keyword, important keyword, is distributed system, where we talk about peer-to-peer, grid computing, cloud computing, cluster computing, and stuff like that. Another important keyword is multi-core processors and parallel applications, parallel computing, virtualizations, open source. And other important things that we are moving toward is like communications, right? Everywhere, mobile system, pervasive computing, or ubiquitous computing, where where basically we have all the how to say, we are connecting everyday objects, right? To we are basically adding microprocessors to everyday object and connecting them to our network. Another way is new way of working. So another keywords that can be considered under 5th generation, like e-science, e-learning, e-business, and all those e-things. Services, service-oriented architectures, that we are moving towards service-oriented architectures and web services. Artificial intelligence, basically resources are requested on demand. So these are the important things we are basically achieved, or we are more talking about them in the 5th generation of computer system. So let's go back a little bit. 1996, okay, when we had basically this type of mainframe workstation, so that in its own time, it was really basically game changers, right? When it comes, so it was basically Sun E10000 Super Mini, and yeah, it was a basically really big deal by its own time, used by eBay, which was basically one of the giant markets by that time. So it has up to 64 processors, 250 megahertz. I mean, we are more or less having, I think we are in the same age, more or less, some of us. So we remember some of these things. So it has 64 gigabyte of RAM, which we can have nowadays on our PC, up to 20 terabyte of disk. While the PC was basically had this type of characteristics. A 200 megahertz CPU, 32-bit RAMs, and 4 gigabyte disk, which was basically pretty much acceptable by 1996. So let's talk about basically history of distributed system cloud computing from Berkeley perspective. So in Berkeley Rad Lab, where they were basically started focusing on basically the idea of making a network of workstation. So we have this workstation, right? Let's say if we call it a workstation. So the idea is basically, the idea was why, the idea was why not to get a lot of workstation, connect them together, and using that, the power, the collaborative power of all those basically workstation, small workstation, let's say not super big workstation, to overwhelm or basically to overpass even the processing power of the mainframe or a supercomputer. So they started with this idea. So they started like this, okay? In 1994, they started basically connecting 4 HP 735s together using some cables. As you can see, it's total mess. They were just doing some practices, and they call it basically the system was called Now. So then, while they were trying to basically sort out what they can do with connecting different, basically small pieces that they could basically find in their desks, right, together to see how they can basically connect them, achieve basically a better performance than one individual of them. So big companies, they sort out that they are up to some things, and they started donating money and systems. So they received this donation from Sun Microsystems that they donated 32 Spark stations. So they were, now everything is forming. It's 1995, they call it version 1 now. And as you can see, it's now become something. It's getting look like our modern, basically, how to say, data centers, right? There are different, basically, computers on rack connected neatly through network cables, switches. So this is basically 1995, and by 1997, they had now 60 some Spark 2. Now you can see it's really now looking professional. So basically, they were up to something really interesting. So then the challenges basically they were facing, the biggest challenge they were facing was how you can program this now. Now is the name of this system that they are basically connecting to each other. Because now they had different, multiple, basically, let's say 60 different computers connected to each other. Some of them can fail, network connection can fail. So the things that we discussed about computer system, like there would be partial failure, there would be some of the system that fail. So they had to be basically they had to sort out how to deal with all those issues. And they published actually in 2009, they published this paper about the cloud, a Berkeley view of cloud computing, which is one of the most cited papers in cloud computing. It has, I don't know, around 10,000 citations received, and it received a lot of attention from universities, from companies. It's not like I'm not claiming, or they are not claiming that they were basically first, okay? But this paper itself started basically making cloud computing as bringing the idea to most of the universities, research institutions, as something that they could basically start working and researching on. So getting back to this, okay, so that was a little bit background history. So now let's talk about this concept and see how we basically move toward all this system. Anyone can define parallel computing? Or concurrent computing?
Maybe just like I was thinking a lot of like, for example, MapReduce that we saw that is breaking like into very small parts and then get each one of them doing them independently and then just someone merging them.
Yes.
I think that the principal difference is with parallel computing, you are going to use one resource until you finish your task. So when you are talking about the concurrency, it's you are going to share the process with different tasks. So I feel like that's the principal difference.
So how is it different with, let's say, distributed computing? Or is it the same concept?
Actually, it's the same. In distributed computing, you are going to work in parallel, like in the Rodrigo example. You are going to share, like in MapReduce, you are going to share the different data in chunks into the different nodes, so you can achieve parallel computing because of this. But at the end, I feel like it's the same, right?
Slight different, okay? There is this really slight different, but we can say most of these concepts are how to say, are classes of parallel computers. Most of these things that we see here are classes of parallel computers. So let's see, like the definition can be type of computation in which a large problem is divided into smaller ones, which can then be solved simultaneously, right? It's a very basic definition. Break the problem, solve them at the same time. But the core idea is basically parallel computation on a shared memory. So basically the idea is that memory is basically uniformly is accessed by all the CPUs. Let's say you have multiple processors doing basically all those broken tasks, right, at the same time, but they are all having access to the shared memory. So we can consider that as basically parallel computing. So then there would
essentially
be,
multi-threading.
yeah, it can be. Sort of that I would argue, I mean, or maybe someone has had different idea that also falls under that parallel computing concept. But parallel multi-threading maybe is a smaller category, I would say. So then the problem with basically parallel computing, or the challenge can be basically, for example, because multiple CPUs are working on the same problem that is divided to smaller problems and having access to shared memory, then they can have basically, the problem would be how to manage basically the data that each CPU has inside the cache, right? How to deal with those things, how to deal with, yeah, that would be maybe a challenge to deal with in parallel computing. But what about distributed computing? I mean, I can claim there is a slight difference between parallel computing and distributed computing. Can you spot it?
I mean, the shared memory, right? In distributed, you have different machines, each with their own memory.
Absolutely, yeah, absolutely. That's the idea actually. So about distributed computing, like for example, Leslie Lamport, the godfather of distributed computing that we
Paxos man.
Yeah, the Paxos man. Paxos man. Once he gave a really interesting talk for tech students actually, and that was really interesting to have him talking to us. So he defined it basically in a sarcastic way that distributed computing is when someone else's computer stops working at their desk, so my task can be done at my own desk. Okay, that's like pessimistic view, but that's more or less how it works, right? The definition is the distributed system is a system whose components are located on a different network computer, which interact with one another in order to achieve a common goal. Again, we have that big problem, but now it's divided to different set of computers located in different parts of basically the network, right? They are connected with the network. So the core idea is doing that parallel computation over the network with distributed memory. Is it clear the difference between these two? So now each CPU has access to its own local memory, right? And then the communication between CPUs take place via network connection. Clear question?
In the other case, in the parallel one, the shared memory needs to be in the same place or can be in a different place.
The shared memory is basically the shared memory accessed by all the CPUs. So we can call that parallel computing. So,
but the shared memory can be in different points, in different nodes.
But I would argue that evenly basically accessed by all the CPU, even if it's no, I wouldn't say it's a different nodes. If you connect them by the network, I would consider that distributed system. From that point, that is the network involved.
If there is no network, then it's shared memory, right?
Yeah, I would say that.
I mean, for example, as you were saying, Pedro, if you were like in AWS terms, if you were to have like an EFS or an EBS, when multiple servers connected to that same EFS or EBS, that would be by this definition parallel, right? Because we have multiple instances that are servers all connected to the same data storage unit. And in that sense, they need to collaborate or do semaphores or whatever to talk in this same shared memory. So even though they are different computers, the via of communication is the same memory. So yeah, that would be parallel, even though we have different servers, right? Yeah.
Confusing, yeah. I want to delete this. It's like okay, it's confusing.
Yeah, this is getting super contentious.
yeah, we don't get but basically, well, I mean, I wanted to highlight the difference between parallel and distributed computing. Let's say when the network involved, you can call it distributed computing. When we started the talk like 5 minutes ago, you were saying it's almost the same. Parallel computing, distributed computing, it's more or less the same. Let's say if they are, because the problem here would be the speed to access the memory. When the memory is directly accessible by CPU, their speed is totally different when two CPU working on their own basically local memories, and the data also shared through the network connection, because network connection is not, I mean, the speed of the network connection, delay, the latency is not comparable at all with the speed that the memory can be accessed by the CPU. So it will be really different challenge, different problems. So if the memory is directly accessible by CPU, it's different speed than the data should be transferred through the network for some cases.
Okay. In parallel computation, we don't need to take care of the time, right?
Not really, no. Because the local things, right?
In distributed, we need to take care of the time, right?
Yeah, in distributed network, definitely you need to deal with that time problem, time synchronization. Yeah.
Okay. Right.
So let's go. So what about grid computing? Is it the same? Is it distributed computing? Is it parallel computing? I'm not saying this. These are just definition as you see. They're just coming from Wikipedia. Okay, so it's not like super academic, like NIST level of definition for them.
Based on that diagram, looks like something like MapReduce, where you can add in, I mean, when you have like a distributed system, the more systems that you add, then there is a performance issue, right? In this kind of situation, I see, like, for example, you start in one place or you spread across 5, 7 nodes, and then you can jump into the more that you add, probably won't impact you in the same way. It's like in a sequential. Sorry, I'm not sure if I am explaining myself, but it's more like a spread the work, like a workflow. Is it that?
Yeah, that is, but how it can be different with distributed computing, or is it the same exactly? I'm not saying it's different. Is it the same? Is different with distributed computing? Again, we can see here like they are connected through the network, right?
Yeah, but they are like peer-to-peer, right?
Pardon?
Like peer-to-peer.
That can be seen too, but let's see. For example, it can be combination of computer resources from multiple administrative domain applied to a common task. So how I would basically say it or define it, I say it's a distributed parallel computation. So it's basically, you can see it as the most distributed form of parallel computing. It's parallel computing in a distributed fashion. So basically you have the network things there, and you have the parallel computing at the same time. Because you have a grid, then this grid is connected to another grid, that grid is connected to another grid. So you can have basically, you can see it as something like this. Again, so you see we're talking parallel computing, is like it's slightly different with distributed computing, slightly different with grid computing, but more or less they are all form of parallelly processing some data, a big problem or something like this, right? So let's say grid computing. Let's stop here. So let's say it's 2005, now data centers are new servers, okay? So then the programs, I mean, basically by then, by 2005-ish, the Sun Microsystem were developing this type of containers, right? So inside they had basically a lot of racks with just normal systems, basically stacked on top of each other, something like that. Now version 2 that Berkeley was developing. Now they have a lot of this type of things, putting them in a container, having basically a port that you can connect a really high speed network cable to it, and maybe water pump to keep it cold. Yeah, because of the heat generation. And the idea with this was because all the infrastructure in the city, in the world, basically, are developed to be able, so we can be able to move everything in the containers, right? So the ships, the roads, the camions, everything is designed for these things, basically. I mean, everything can carry, and we can carry this thing through all our infrastructure. So that was the idea. So the idea is now you have this, so you can basically have a lot of them parked next to each other and connect them to each other. Now you can have that data center. And basically this is not just the idea, but this was the reality by then. So basically there had hundreds of computers, storage network, and they had warehouse size facilities and workload and having this type of things. So 2006-ish, utility computing arrives. So by around that time, okay, so Amazon Elastic Compute Cloud was introduced. So I heard from a talk that it was the first time actually the cloud concept was introduced, okay, that the word, okay, the concept was there, okay, from a long time ago. But the word as a cloud, like, introduced by Amazon somehow, and they introduced this. So you could basically rent this type of units for 8 cents per hour, and you have basically this type of setup. You could have a small instance, large or extra large instance for different prices. You would access this type of platform, this type of core, this type of memory, and this type of storage. So the idea with utility computing was basically, why not using computer or processing power as another utility that you can rent, can return, right? So there wasn't any upfront cost, no contract, no minimum. The billing rounded to the nearest hour, pay as you go, right? And that's the very important keywords. These are the important keywords, right? All these are the important keywords in cloud computing when we are talking about. This is especially pay as you go. This is maybe the most important keywords when we are using cloud computing. So it was a new paradigm for deploying services by then. Basically, it was becoming something like that. And the idea actually, for the interesting thing for all these things, the Amazon coming up with this idea is not like really they were looking to implement or to come up with a cloud computing as the technology we know now. The idea was Amazon was receiving basically millions of requests, right? A lot of customers, they had to just keep scaling, right? And there would be Prime days, they would have tons of more customers at some point. Then the demand was fluctuating, it wouldn't be the same, okay? So they had to basically buy a lot of these type of systems, okay? Warehouses. They had to have a lot of these warehouses, and it was not used all the times. At some of the times, for example, nowadays the economy is like more globalized, okay? So you can say Amazon always have peak, right? Always have a lot of basically traffic, but maybe by then, most of the traffic is generated in US. Then there would be midnight, 1, 2 a.m., the traffic load goes down. So you have all these facilities and they are being unused. No one is using them. So why not rent them out, right? While the load is small. So you have it, just rent them when you're not using it. So you can basically generate extra income. So basically that's the whole idea. I mean, we started from there and it becomes such a giant thing, right? So what is utility computing? So the packaging of computing resources, computation storage, memory as a metered service similar to traditional public utilities, right? Electricity, like gas, right? Just you pay as much as you consume. You pay your water bill, you pay your electricity bill as much as you consume. That's a utility, right? So basically the idea of utility computing is the same thing. So it wasn't actually a new concept, as you can see from this 1961, but basically note by John McCarthy from MIT. He says, if computers of the kind I have advocated become the computers of the future, then the computing may someday be organized as a public utility. Just as the telephone system is a public utility, the computer utility could become the basis of a new and important industry. So now you're talking 1961. Really such a visionary person. From 1961, you could see what was happening in 2000, basically in 2020. So, but what about cloud computing? We talked about parallel computing, distributed computing, grid computing, utility computing. What is cloud computing? Is it a combination of all? Is it some of them mixed? It's a little bit hard to define, okay? So it can mean different to different parties when we're talking about cloud computing. But in order to facilitate and make our life easier, let's go with NIST, National Institute of Standards and Technology definition for what is it cloud computing. So as it says, I read it, cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. For example, network server, storage, application, and services that can be rapidly provisioned and released, right? Provisioned and released with minimal management effort and other important things, or service provider interaction. This cloud model promotes availability and other things, right? Important keyword, and is composed of 5 essential characteristics, 3 service models, and 4 deployment models. We're going to talk about this in detail. So this is an official NIST definition of cloud computing. You can find it. It's a 2-page document. You can find it here. 2-page PDF. You can download it here and you can read it, the official definition. But let's basically break it to important keyword. As we said, it's on-demand access, right? That's very important when we are talking about cloud computing. To a shared pool of configurable resources, right? These are other important points in cloud computing. That can be rapidly provisioned, minimal management. These are important characteristics. Availability, of course, keywords, and it's composed of these things. So let's go to discuss all this. For example, what is 5 essential characteristics of cloud computing? So the first one is a on-demand self-service. So it can be seen as basically for on-demand self-service, a consumer should be able to unilaterally provision computing capabilities without human interaction with the service provider. Exactly how it's happened, right? You just go to the system, you sign into your account, and you start using whatever you want, however you want, right? Without any interaction with that, without any human interaction with the service provider. There is nothing, absolutely, right? And by computing capabilities, we mean server time, network storage, number of services. So this is the first characteristic, on-demand self-service. The second one is the broad network access. So the capabilities are available over the network. The system is available over the network, right? Through all sort of basically different mechanism, through your mobile phone, laptop, anything you can imagine, right? All sorts of devices that can be connected to the system, it is available to. So this is the second essential characteristics of the cloud computing. So the first essential characteristics, on-demand self-service. Second one, broad network access. The third one is multi-tenancy or resource pooling. So basically the idea is the customer generally has no control or knowledge over the exact location of the servers, right? You don't know exactly where you're connecting to. Or those are the basically things that we don't know as an end user. And so it provides computing resources that are pooled to serve multiple consumers. It's multi-tenancy, right? And the computing resources, again, we are talking about storage, processing, memory, network bandwidth, and all those things. And it's location independent, and it has major. But when we're talking about this multi-tenancy, so you can think about the challenges that it can be arise, right? So the performance of the system, the scalability of the system, how to make it scalable, and of course, a very important keyword would be another important challenge would be securing all those systems. So the fourth essential characteristic is the rapid elasticity. This is the basically very well known, right? So the capabilities can be rapidly and elastically provisioned, right? You can basically scale up, scale down rapidly without any problem. That's very essential characteristics of cloud computing. So it's kind of hard to predict a ceiling for our services. You don't know exactly where is the limits, right? You scale up, and you see it's just scaling up without you really hitting the ceiling, right? And you can do that quickly, scaling up and scaling down. So basically, it gives you this idea that you have somehow unlimited virtual resources. And the fifth and last characteristic, essential characteristic, is the measured services. So basically, you can measure the usage of the users, right? So you can basically, the system can automatically control and optimize resources. And it can basically leverage all those basically metering capabilities at some level, right? So basically it can measure how much you're using it, how much basically you use storage, processing bandwidth, and all those things. All good, all clear? So these are basically 5 essential characteristics according to the NIST. We were talking about these 5 essential characteristics. Now let's talk about 3 service models. So the first one, most maybe common one, or most old one, not a new concept, like a software as a service. So in software as a service, basically, service providers provide application on cloud infrastructure for end users. So it is network-based access, it's multi-tenancy, the same thing that we discussed, and it's single software release for all the users, for all the end users. So again, so the applications are accessible for the various clients. So as an example of SaaS or software as a service, we can talk about Salesforce, Google Doc, and so many other things. So this is you're talking about 3 service models. So SaaS is one of them, software as a service. So we thought the applications are multi-tenant application. So yeah, the applications are net native, right? They are based on the net. So what I mean by net native, the characteristic of net native applications are there are cloud-specific design. They are multi-tenants. They can basically multiple users can use them at the same time. They have built-in metering and management for how users is using, how much they're consuming, processing power, memory, and storage. They are browser-based clients, and they have client tools, and they can basically be configured through some level of customization. You have access, not a lot, but to some level of customization. But talk about this basically the disadvantages of software as a service. Its dependency on network cloud service providers is one disadvantage because it's not local anymore. So if you basically you miss the network connection, you missed access to this, right? Or if the cloud service provider is down for any reason, you missed access. Performance is limited to client bandwidth. The performance of the application will be somehow limited by the bandwidth of the network you're using. Another challenge or disadvantage can be security. It is, of course, good. You can have better security than personal computers because there's a backup, there's all those replicas things that you were discussing in distributed computing is also applied to cloud, of course. The bad thing is your cloud service provider is in charge of the data in their system. And the ugly side of it is the user privacy. So let's move to the second one. Second service model or platform as a service. So now that last time you just had the software that you were using it in a cloud infrastructure, here you have the whole platform. So basically the vendor provides development environment for the end user. And but again, the tools and technology is selected by the vendors, not by the end users. And the vendors has control over data life cycle. The advantages is rapid deployment and development. So small startups can basically, a small startup cost, that basically you can, with a small amount of money, a small skill set, you can have really a good set of basically systems under your hand, right? So basically you have that powerful platform with a really small amount of money. So the characteristics is multi-tenancy again, one of the important one, the native scalability, native integrated management. So I'll go these things a little bit faster. I assume a lot of you are familiar with this type of concept. So in the platform as a service, basically customers is able to deploy onto the cloud infrastructure an application that they developed, okay, or they're acquired. Either you can develop your own application on the platform, or you can deploy the acquired software in their platform. The disadvantages can be all the disadvantages from software as a service. And another, apart from those disadvantages, one more can be the choice of the development technology is limited to vendor provided or supported tools and services. So I assume, for example, Pedro, that working in Oracle, it can affirm this is one problem. Now we have some undergraduate students working with Oracle, with OCI, so there's some challenges because it just supports certain things. So as an example, the Google App Engine can be seen as a platform as a service. The last service model, according to the NIST, is infrastructure as a service. Now, in this case, basically, customer is able, you have the whole infrastructure, right? You are able to, the customer is able to deploy or run softwares, which can include also operating systems and applications. Now you have the infrastructure. You're not just having the platform, right? You have more flexibility. So, but again, in this case, customer does not manage or control underlying infrastructure of the underlying cloud infrastructure, but they can control their operating system storage, deployed application. They can control those details. So they have more control, right? Because now they have the whole infrastructure as their service. The advantages can be infrastructure scalability, native integrated management, the performance, the cost again. You can basically economical cost. You can have the whole advanced really infrastructure with really low cost comparing to acquiring all of them, buying all those infrastructure. You can have it basically with a really low cost. The example can be basically Amazon Elastic Compute Cloud, the most famous one. So those are infrastructure as service. So we talked about software as service, platform as service, and infrastructure as service. So basically, this is basically would be SaaS, right? The least one, less flexible, more constrained, and less effort. It's much easier. You just go to the system and you start using the application. These are more flexible, less constrained. So it would be basically infrastructure as a service. It would be more flexible. You have more flexibility already, but of course, it required more effort because you have to do more things to set up your system. All good so far?
I have a question. Regarding the privacy, it said it's ugly, but I didn't get at all why it's ugly about privacy.
You're talking about this one, right? You're talking about software as a service. So you're using a software in a service provider system. So you absolutely have no privacy. Yeah, everything you're doing is observed. Everything you're doing, all the activities are logged. Everything is basically under monitored. So the privacy is, you lose it. I mean, comparing to, I don't want to go with weird examples, but yeah, you don't have privacy. Imagine editing something.
But there are contracts, right?
Pardon?
But there are contracts.
There are, but it's still all your activities are logged.
Yeah, but I mean, yeah, they have your information, but by contract, they cannot use your information.
Well, it depends on the
By
application,
contracts.
right?
I mean,
Depends, yeah.
At the end of the day, they can do whatever they want because the information is there.
Yeah, absolutely. Imagine editing a picture in Photoshop online, right? Or editing a video. You don't have privacy. I mean, maybe you want to do weird things. I don't know.
I imagine bank, financial institutions, I guess, well, all of that transactions, I guess they don't want to have someone looking at that. So I guess financial institutions don't like, I mean, the public clouds, right?
Not
I guess.
necessarily. No, I mean that I wouldn't say that falls under the problem of privacy. That's another thing. But privacy would be mainly, I would say, for really individual users. I mean, that becomes the biggest problem. I mean, financial institutions, they don't have really much things to hide from hiding from. Like, let's say Morgan Stanley wants to hide the financial information from Amazon, but I don't think there would be any issue there. I based on my understanding, but for the users, really, I mean, when you're using software as a service to privacy, I mean, if you have privacy concern, for whatever reason, this is not really a choice.
Do you remember, Gautier, the problem that was like 10 years ago or less, when the full I don't know how you say, but the full address, well, not address, padrón, I don't know what to say, padrón electoral,
right,
was shared online on AWS.
Yeah,
that is
I
a
remember it.
security issue.
That they made public all the information that they have an AWS public bucket.
No, but I mean, you're talking about like a data leak, right? I believe user privacy is like if you are using Google Docs to type your journal and who you are in love with and your life story, you are using Google servers, Google's program. Who knows who's reading that? Who knows who's storing that? Who knows who's sharing that information? So there are like end user license agreements or whatever, like the usage data agreements, but still it's not your application, it's not your computer, you have no idea what's going on under the hood. So if you're concerned about how they're using your privacy, like do not use Google Doc as a journal, right? Or as a, like you're typing your company secrets in a Google Doc, right?
Yeah, absolutely.
A lot of companies use Google Docs for that because they are
true.
I think it's about
they probably shouldn't.
But like, I'm not really sure because also, for example, let's imagine right now that it's super common S3, for example, that depending of you can make, as I mentioned, like a public, like make the buckets, it's called bucket, each like folder, let's say, virtual folders, right? So you can make it public or you can make it private, and depending on the role that you have, who has access and who has not access. And also there are like, when you actually how you say start using the service, there are some agreements about the privacy that they cannot read the information, they can store the information. That's one thing, right? Each company make the use as they want, but if they make something public to other people, or they do some, like they don't program correctly the roles, for example, or the access, that's a different concern, right? That doesn't mean about like the data being hosted like in Amazon, that they are going to do something with that. It's more about the company, how they are going to make use of that, each developer, right? Because
and misconfiguration, that can lead to security issues. But again, go ahead.
Yeah, because for example, the government here in the United States, it's okay with some, like, for example, if you want to create a company, you have to talk about the security. Well, if you want to talk about the security concerns, and if it's going to be the web domain, like it's going to be public for everybody, and you want to use, like, let's say AWS, you can have like a contract where it states why your information is going to be protected, because right now a lot of companies do that. For example, they use S3 for government purposes, you know, but that's like and that's more in implementation side rather than about where are you storing your data and contract. I don't know.
Yeah, but I mean, I don't think S3 and Google Docs are in the same ballpark, right? Like Google Doc is a SaaS, and S3 is just like a network storage.
Well,
So
yeah, either way, like let's say in Google Docs is similar because for documentation, for example, I was working at Google and Amazon, and at Amazon, sometimes they use Google Docs actually, for some things. It's really funny, but they use also at Google, they use Google Docs for everything, and they use the generic APIs for that. I mean, my current company, they use also Google Docs for that, for example, and they have information about government, like system architecture and things like that. So it's
scary,
the same.
scary stuff.
It's the same. It's about like permissions, like configuration, like roles and accessibility, things like that.
Yeah, I mean, things goes fine till it doesn't anymore, That's always the case. I mean, everything is okay till it's no more okay. I mean, for whatever reason. I mean, again, to me, I mean, the biggest concern wouldn't come from, I would say, not the basically big corporate, but from the government at the end. No matter your Apple, your Amazon, your Google, you're still working under the same rules. And when it's needed, your data would be available for them, for sure, if it needed. So anyway, that's the things about the privacy. That's what we were I was trying to highlight there. So you can look at these service models and control in this way, right? So we can have all the way from basically from in-house deployment, when you have basically a network that is controlled by organization and service providers. Then you have your storage that is controlled by the organization, basically that you are working for, or personal, let's say organization. And you have server, virtual machine, apps, data. So you have all this organization control. While all the way to the SaaS, right? You have control on the data that you're uploading or you're using, you're sending to the basically you're using the data for that software. Everything else is under the service provider controls. So, but again, as we discussed, infrastructure as a service has more you have more freedom. You have freedom over data, application, even how to maybe set up your virtual machine operating system. In platform as a service, you have less controls, and in basically software as a service, you have the least control. Right, the service providers has the biggest control. So you can basically you can visualize it in this manner as well. There's a chat message, aren't there's encryption strategy? But not really. I don't think there is. I mean, encryption this is not a silver bullet can solve everything now. So is that everything? Like software as a service, platform as a service, infrastructure as a service. Now we talk everything as a service, okay, or X or X for whatever, okay, as a service, everything as a service. It can be basically seen as composite second level services, security as a service. So for example, in the case of McAfee, you can have McAfee SaaS email archiving, McAfee SaaS email inbound filtering, and all those things. So basically, now we are talking, I mean, if you just Google this part, there are tons of things, right? There are tons of things, even they have, I don't know, for example, phishing that they can have a lot of basically security attacks as a service. You can find them in dark web. You can basically buy, you can do all those activities as a services. They just tell you based on how much you're using them. Or communication as a service. In the case are like VoIP, private PBX. The PBX is a private branch exchange, is a business telephone systems. Questions so far? All good?
Yeah.
So this can be seen again, like a simple reference model can be seen like this. You have SaaS, PaaS, IaaS, I don't know how to say those things. Then you have all those management, security monitoring, metering services from the service providers, and you can basically use any type of these things with this type of, for example, for infrastructure, you have virtualization and storage infrastructure. For platform, you have services, that's cloud runtime, and for the application, you have the application under your control. So let's talk basically wrap up by talking about for deployment model. The for deployment model is the private cloud that is basically the cloud infrastructure that is operated solely for an organization. And it basically, yeah, they can have it in their how to say, premise, or you can have it outside premise. That's a private cloud. We can have community cloud, okay, which basically can support a specific community. The community can be basically, maybe the communities are that having shared concern, okay, they have shared mission, they have shared security requirements, same policy, or whatever it is. It can be seen as a community cloud. So we have basically 4 different models: deployment model, private cloud, community cloud, public cloud, and hybrid cloud. As the name suggests, public cloud is infrastructure made available for the general public, but it's still owned by organization selling that cloud services. And the hybrid cloud can be basically any composition of 2, 3 of these different deployment models. So nothing complicated about deployment model. It can be private, community, public, or mix of all these things. So this can give us basically broad pictures of cloud computing based on NIST definition. You have software as a service, platform as a service, infrastructure as a service. We can have it private, we can have it community, hybrid, or public cloud. And the essential characteristics that they all providing are these things: broad network access, measured services that can measure how much the user is using the system, the storage, the processing power. It should be accessed over the network. On-demand self-services, there is a minimum, basically, human interaction. Rapid elasticity, you can scale up and down rapidly, and basically you can do a resource pooling. Clear? So we walk through the definition of the NIST, and we discuss all those details on the definition. So what's new anyway? Okay. The old idea was software as a service. It's not really a new idea. Software hosted in infrastructure basis installed on a local server or desktop. It's not really, let's say, it's not really modern definition. Okay, what is the new, let's say, more or less, is that pay-as-you-go utility computing. You can use all those computing services, can be processing, storage, memory, and bandwidth, all those things, and you can use it as in a pay-as-you-go fashion. Like you do that for water, you do that for electricity and stuff like that. Questions?
Just a comment. I was involved in a project that now is known publicly. That, for example, Intel is creating a CPU that fits with this cloud computing terminology, where the CPU can be upgraded or downgraded as needed. For example, the number of cores or the memory bandwidth, factors like that. So it seems that the business is heading towards to cloud computing in some areas.
Yeah, absolutely. I mean, that's what I'm referring to as a processing power. You can scale up and down, not just memory storage. It's about also processing power, how much you're going to use, how much processing power you need.
The new thing is that not even, for example, one can imagine that if you pay for more power and they add a server for you, but now it's a component thing. The CPU can increase its features, not
Yeah,
only the system.
it's like really weird that if you I don't know, you buy one CPU as you said, and then you apply something called the SKUs, that you have like an encryption code, and then you apply that encryption to the CPU, and you receive the upgrades on and so many kind of things like available cores or accelerators of the new technology like load balancers and quick assist technology on all that stuff. It's really interesting that enterprise model.
Yeah, true. It is actually. To be honest, I don't have really experience or much experience on really having hands-on experience or doing things on cloud, because I never been a programmer. I never worked in private companies really, but all my life was academia theory. So most probably you know a lot more about these things than me, a lot more. And I'm really curious and excited to learn from you during the presentation, to hear more about these things from you too. So let's talk about the economic briefly too, okay? So the most important keyword is pay as you go, right? So basically you have the systems, they can charge you basically per minutes, per hours, per day, how much you're using. And that's the interesting things actually that is demonstrated using these pictures. Imagine you have certain, basically you acquire certain capacity. Okay, it's like, for example, imagine you're statistically provision certain capacity, okay? So, but the demand is not always basically linear. The demand can go up, go down. So when the demand is up, maybe if your capacity is enough, you're reaching almost your capacity or reaching your capacity. But when the demand goes low, you have a lot of unused resources, right? And staying there for no reason. But while it's basically in the cloud, basically structure, you can have that capacity and demand basically more aligned, so you don't, basically you are not wasting any resources, right? So this is from users' perspective, from the users, how they are seeing this. So that elasticity, like for example, using 100,000 servers for 1 hour can cost the same as 1 server for 1,000 hours. So that's the magic of cloud computing, right? You can do your task, you can acquire more resources, do your task in way shorter time, comparing to just using less resources and taking much longer time. If you're doing machine learning, training your data, you can feel this, or for, I don't know, whatever, rendering, video rendering, or whatever it is, 3D rendering, you can feel this really basically amazing things. So basically you can pay the same price, right? But get the result faster. What else? So these are from basically from the user's perspective. So also there is basically the risk of underutilization. Underutilization results if peak predictions are too optimistic. For example, you open, I don't know, you develop something, a system, an application. You think you're gonna have, in the peak time, you're gonna have 10,000 users, but you never reach that. You provided that capacity, but your demand never reached that, right? So you may underutilize your, basically the capacity, the resources that you have. Or basically you may under provision your basically capacity. Imagine the demand goes up, but the capacity is limited. So the problem can basically arises there. Right, that's like worst case scenario. I mean, the capacity cannot keep up with the demands in its peak, right? And that's and the demand is like this for most of the things we are using. Is apart from like massive corporation that they have users all over the world, and they are always daytime somewhere and peak time. But most of the time is like demand is ups and down for a lot of things. Some I don't know, whatever application suddenly becomes popular, the demands skyrockets, so the capacity should keep up, then it goes and it fade away in 2 months. So that basically you don't want to have a fixed capacity, right? A statistically allocate, basically a static allocation capacity. So in this particular case, for example, if your capacity cannot keep up with demand, you're going to lose revenue. And in the other case, you might basically lose user as well, right? Because the capacity cannot keep up, the users will be unsatisfied, start fading away until basically the system dies, the application, the service dies, like what happens to Friendsters, right? Before Facebook. They couldn't keep up with the demands and it's kaput. So from the provider's perspective, they have economies of scales, okay? They can have purchasing, powering, and managing machines at scales, so that gives them lower per unit cost than customers. So there was basically studies that it can basically cost them 7 times lower prices when they are buying in massive scales from chip providers, from memory providers, and so on. So they can scale, basically, they can reduce the price, okay, a lot. Let me see how many, yeah, almost, let me see how many slides left. So I think I can finish it if you keep on 5 more minutes, okay? So we can finish it, so I don't need to carry it over the next class for no reason. So the data centers are exactly what we were discussing, what, let's say, Berkeley was doing in that their now system, right? Just normal system, that they have CPU, RAM, disks, pile them up together, put them on rack, connect them to each other, right? Then you have all these racks, put all the racks together and achieve basically massive power, processing power, and storage power. So for example, from the computing, basically hardware, they have, the basic is like multi-core CPU servers, stuff like this. The new things are GPUs, PGAs, and custom accelerators. So those are the new concepts. Assume you're familiar with, for example, some of these are, for example, this is claimed to be how to say the most advanced data center CPU ever built at NVIDIA Tesla. This is the Microsoft Catapult, is the Microsoft initiatives to transform basically cloud computing by having basically FPGAs in it, okay? And basically the tensor processing units from the Google that's making a lot of buzz recently. So those are basically the new things. I mean, these are the basic things from the clouds. When we talk about the storage, this bunch of disks array that you make an array of different hard disks. These are the disk trays. They are basically the basics, right? SSDs and this let's say new non-volatile memories, that they are basically new type of technology used in data centers. What else? And the networking, again, the basics are the switches, the bit switches, stuff like this. The new things are software-defined networking, which is becoming basically definitely future. This it's basically smart NICs. So that to accelerate basically networking, storage, security function and all those things, and of course, FPGAs. These are the, I'm just putting this couple of slides to see what is basically we know already, okay, what are the new things happening in the data centers. Of course, data centers have multi-core CPUs, processing power, definitely they are, but GPUs, FPGAs, this type of things are new sort of technologies, we can call them, that are basically incorporated in data centers, like this type of things, non-volatile memories, that are modern things, and these are the things that like normal RAMs, normal hard disk, that are, let's say, traditional things or traditional switches versus the new things that are developed. So there's this useful latency numbers. I just pass just to compare the latency of the data processing, how fast basically a CPU can reach to L1 cache, and how you can compare that with sending packet from California to Europe and back to California. How in nanosecond, how much that takes time. So you can see again, it's still the smallest link or lowest links are still network, and probably it will be ever, because we cannot go faster than the speed of light. So this is theoretical limit, right? We cannot bypass. And the throughput numbers, again, what is the speed of the bandwidth speed for DDR4 RAMs and all those other technologies. So summary, cloud computing democratized somehow access to supercomputer class capabilities for even normal users, for academia, for individual peoples. So it can put students, academia on more level playing field with high impact, but to have high impact industry. So basically a group of developers, 5 person can now really compete with giant corporation somehow. So the next Google, eBay, Amazon. So this eBay is like, this is coming from all the style. Okay, that time eBay was a big deal. No more. Okay, so yeah, the next Google, Amazon, Facebook can come from a small group of basically developers with amazing ideas. So just food for your thoughts. Is this concept the only benefits? Okay. So I want to invite you to think about this type of question. Who decides which application we are allowed to use in the future? Who decides which books we are allowed to read in the future? Because you have everything now in the cloud, right? Your Amazon can control what type of book you are reading. They can just remotely wipe any book they don't want you read. How much freedom and self-determination do we give up on these technologies, right? Like top 10 listed apps. I'm not saying it's all bad. Okay, it can be good. For example, if there is a whatever weird apps there, of course it should be removed, it shouldn't be accessed. But to what extent you can trust your basically your judgments, right? Or there are cases like Amazon just block all Android users from purchasing Kindle ebooks, or Amazon erases Orwell books from Kindle. For this was, I don't want to make it like it's such a big deal. This was for copyright purpose, but they have the power now. They can control certain things or a lot of things. Google can remotely wipe the application of your Android phones. Apple can do that from your iPhones, right? So we are giving a lot of things. We are giving up a lot of things, right, to gain those things. So now, for example, in Chromium OS, all applications are web application. Everything is web application now. So these are the things just to think about, to have in mind. Okay, it's basically when you're gaining something, we are giving up something. Okay, it's not always good things, right? So yeah, that's all from me. I mean, it's like every first class, it took long. I remember the distributed system took like sharp 3 hours. I think I even passed like 10 minutes extra to finish this live. Sorry, okay. So, oh, okay, wait a minute. The most important thing is remain. Discord. So I'm gonna send you certain links. So let me see.
Yeah, I don't know if the others have access already to that course because for me it doesn't appear.
No, I was telling you, no one appears. So if I go
Okay.
here, there isn't any student name. So I'm the only one here. Okay.
There are happening a lot of things with the tech applications, right? Because, for example, I still don't see the grade for my last course. It's still in calificación.
Unfortunately, yeah, unfortunately, is a big problem. It's totally out of my control. So totally, I mean, I have no control on it. But you all received my email, right?
Yeah.
So just let me send you this link in the chat because I want this is the important one. I want you to open right now to check it out. Make sure you have access. You have the right access. So these are the name of the students. Here we have everyone. And these are the presentation slots. So we have for the next week, which is 18 August, we have 2 presentations. The first paper is Cloud Programming Simplified, a Berkeley view on serverless computing. Let me make it bigger. No. So these are the two first paper. I want to basically volunteer. If there is no volunteers, I can just randomize names there and just happen whatever you follow. But if you are a volunteer to present this one as a presenter, as a discussion leader, and note taker.
I would love it.
Yeah, just go ahead. Anyone put the name first, it goes.
I cannot edit.
You cannot edit.
Nope.
Madi,
yes.
One question. We have to present two papers, right?
2 papers throughout the semester. Yeah.
Okay. And 2 discussion leader and 2 note taker.
Yeah.
Okay.
Yeah. So the note taker is basically like nothing. You just keep noting, typing the things. I mean, even if you're recording, so we have it. But and other things, Scott, a lot of things. So as you heard from the students, is a lot of students are not here physically in Guadalajara. Okay. That was the new things to me too. Just today at 5 p.m. I heard that. Because when I emailed you actually at noon. So what do you think? Should the class be online? It can't be presential really for the students that they are not here physically. Anyone has a problem with online classes?
No.
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 I have a strong preference for online class.
Okay. Preference. I assume it's like computer scientists are like they enjoy being behind computers. So, but just in case, is anyone wants, please you can text me. If you want to just raise your hand, you can text me a chat. I mean, send a private message in chat to me that you prefer presential class, so we can think of some solution that I can't imagine what solution can be, because it definitely can be presential 100% because there aren't people, they are not here. So you cannot edit this, no?
No.
You can. You should sign in with your tech ID.
Yeah. I'm
So
with the tech ID.
Editor. So you should be able to edit. So it says everyone from Tecnológico de Monterrey can be editor. Anyone can edit. So Anyone with the link can edit. Let's see. Try again, refresh, please.
Now it says it's protected.
Yeah, I think there are the cells.
Yeah,
maybe.
the
The
first three
cell?
columns are protected. We can type in presentation link, like we can write there, but not in the first three.
Oh, yeah.
A problem has occurred. You're trying to modify a cell or protected object.
Protect range. Set permission. Let's see. Restrict who can. There is something here. Remove. Sorry. Try another refresh. Sorry.
Yeah, that worked.
Okay. So Fernanda want to present the first one. That was fast, Fernanda.
Sorry.
No,
I-
it's okay. They're all interesting. So this is actually 30 something pages for your information.
Hey, Alejandra.
But they are really good paper. I mean, I checked
It's a
them.
battle. What is happening there?
But they are really good. They're both really good paper. And I'm gonna show you the papers. So
Yeah, if you could put the link in the same document, that would be amazing.
yeah, I just put links. Links. So the drive. This is the drive.
Fer, so you are going to present the first one.
So somebody copy pasted my name several times. I don't know who.
Don't overwrite
The
each
paper.
other's name.
There is a paper called Paul Gallegos.
Why do the people paste Paul Gallegos everywhere?
What? What's
They copy my
happening?
name everywhere. I don't know. I was like, why Paul Gallegos like everywhere? I
What
just
is this?
deleted.
Don't mess up with this document, please. That's why I was restricting.
Rule of the internet, Maddie, sorry.
Like,
So
yeah, I
we
can
have,
see that.
I mean, the first two are the most important one. I want a discussion leader for the first paper. Anyone interested in serverless computing?
I can be the one. Discussion. Oh, okay.
Okay,
There's
well,
already
we-
one there.
No, go on, Pedro. You talk first.
Okay, I can be in that one.
What exactly should be doing the discussion leader?
Pardon?
What the discussion leader should be doing? I'm a little bit confused.
The discussion leader is basically the same one as a presentation, just doesn't present. But it should have, he or she should have really good basic understanding from the paper.
Why you're putting your name if you don't know the name of the paper?
They're
It's
playing
because I'm
Russian
the race.
roulette.
Yeah, exactly.
I know my chances. I can take it.
Just take the shot.
I mean, just for me to know that I'm still there for
I'm gonna
something.
put one very math heavy paper here, so I wanna see.
No, no, please don't.
Yeah, so that you reconsider what you're doing with your
Yeah.
life.
I mean, after we are done with this one, he'll just go on, block the column
yeah,
again, and
so
start
just-
getting the papers.
Just the first two leads. This one. Anyone?
I am Maddie.
You want Pedro?
Yeah.
Pedro.
Pedro Cortes. Don't mess up with it.
So you are going to share the link of the paper, or
Yeah, I'll protect range. So you don't mess it up. So one.
it is missing a technology.
Take care.
So So
We are
who
missing
wants
the
to
note
take
taker.
note here?
I can take note.
Okay. Who said that? Rodrigo.
Yeah, I will do.
Okay. So
Protect them
also,
quickly before someone else overwrites them.
Yeah, we're done.
so yeah, I mean, you can put whatever you want, okay? But the important thing here, because I'm not even telling you what is it till next week, okay?
Okay.
Please upload all the papers
But
so
the,
we can start reading.
papers, I mean, just for your information, the papers are basically no math paper. There isn't impact. It's just theoretical concept on cloud computing. So it's just like a reading a story. And this has come from Berkeley. Definitely you will enjoy reading. And other things, everyone's supposed to read the paper, okay? And if you go to the link, I put a link from the basically shared drive. If you go to that link, you find the papers here.
Okay, got it.
So this is paper 1, this is the paper 2, this is extra reading. I encourage you to check. The first one, this 01 is a hypercycle for cloud computing from Gartner, 2022, latest report on cloud computing from Gartner. So if you want to see what's happening there about the hype cycle, what would be the future, you know, where we are at the hype cycle based on all the concept in cloud computing, check this out. It's 100-something pages. You don't need to read everything, but it's really great to have it for reference because you can get really good information here, good knowledge. What can be the future of it? Okay. And this 001 is that 1999 paper, 2009 paper from cloud, the one that I said, one of the most highly cited papers in cloud computing. So I also really suggest reading this. I mean, if you really if you enjoy reading papers, academic papers, this is amazing. You should check it out. And it's it's from 2009, so you can see how they were seeing it, what they were basically predicting 13 years ago. So I think we are all set for the next class. So this one I'm going to remove this.
How many participations should we have? Because I'm seeing
two.
Two? Only two?
Yeah.
I'm seeing
Only.
Have,
and other things, please fill up this page, general information. Because if I try to design any group activities, I want to group them based on the shared interest and basically the work experience. I want to consider everything if there is any group activity. I'm not saying there would be, but I'm saying just in case.
Okay.
Yeah, hopefully there isn't any information that you don't like to share. Okay, but if there is, just don't put it there. What else? So we have this set.
For that page, Mari, I saw that most of the people put their name twice, but I think we need to present everyone's need to present before the partial 1 and then for partial 2, right?
Good point. Yeah, that's good. I mean, I want, for example, everyone present, then the second round. Okay, not that you present first, that second week you present again. So it could be like basically evenly distributed. So I would take care of those things. Okay, I would eliminate the names if, for example, I'll take care of it. Okay, because just today I got the list of the students. Just today I got to know that there are 21 students in the class. So I had absolutely no idea about anything about this course. Okay. So I will manage this. I will put the date. I will basically make sure to separate. This is the first half. Everyone should do one presentation, one discussion, one note taker. and then we can set the second half of the course.
Okay.
So for the next class, that's my task. I come up with this one. I come up with that 50% missing grade about the activity, how we can do that. And yeah, I think everything is settled. So presentation slot, this is the general information, and this is the link for the shared drive. So you can find the papers here. So this is the number one, this is the second one. So this is 33 page, but amazing read, definitely. You will definitely enjoy this. And this is 2. This is 18 page, but double column, so it's almost the same. So the task is reading 2 papers for the next class, before the next class.
Okay.
Sounds good.
Probably just an idea I'm sharing with you, but I will confirm next week. Probably I consider like big chunk of the grade, okay, for the participation in the discussion. I might even go like 20% participation of the students for the discussion. So I want to make sure that you're reading the papers, okay? It's not just that 2 students reading paper. Everyone read the paper, so I want like active participation in the discussion. So maybe I keep track of it and then assign big chunk of the grade to how much you're participating in the discussion.
Okay. I'm going to be the first lead for the discussion. So I don't have any background. What do you expect of the discussion leader?
Just read the paper 2-3 times, you'll be fine. Okay. So I mean, if you are presenting this, you also need to read this one, okay? But you're not just presenting, you're not doing anything. So if you're basically, that's how it works.
Yeah, but I know, for example, a presenter what need to do. He needs to read, do a presentation, and present what he thinks is important, and try to make the other people understand what is explained in the paper. But the discussion leader, do I need to create questions?
No, you don't need to. As long as you come to the class with a good background, with the knowledge on the paper, you will. I mean, I'll be there. I mean, it's not like I'm not going to be there. I'll manage it, and we'll learn together. Okay. So basically, the idea is, as I said, helping to having basically to leading discussion and also to answering questions and doubt of the students.
Okay.
I mean, did you say that we need to download the articles in your shared drive?
Yeah, here.
Where's the link? I can
The
find.
link is here.
Ah, okay, sorry.
If you go to the link, you'll see this one. I mean, I'm putting this here because you don't have access to that, to this one. And the link for Amazon goes here.
Sorry, yeah.
So any question? If not, we can. All good? But if there was any doubt, question, email, my email. This is my email. Just email me if you have any doubt or concern or question. And I'll make sure by next week the problem is solved for the Canvas. So you can have everything here, so I can put the paper here so you can access them easily. But anyway, this works too. So for the presentation, please put a publicly accessible presentation file here, okay? I suggest you use Google Slides, so you can put just a slide here so everyone can have access the day of the presentation. So things changed here.
You have to present twice, but also be twice discussion leader and twice note taker. Oh, no, internet.
If there is any problem here, so let me tell me to resolve. If not, we can meet next week. It's almost, it's too late. I know you should be tired.
Okay.
All good? Okay, perfect. So see you guys next week.
Okay.
Have a nice evening. Rest well.
See ya. You
Thanks.
too.
If any, by the chance, any question, please let me know. Okay.
Okay.
Okay, thank you.
Perfect.
Thank you, bye.
Thank you,
Good night.
guys.
Good night to everyone.
Good night.
you.
Bye.
Bye-bye.
Bye.